you're going to come across two different types of graphs. You're going to have one is called continuous and one is discrete. So let me show you the difference. So here you can see we have a graph for students and number of pets. And in this example, we have a graph for the age and the height. So the difference between a continuous graph and a discrete graph is this. A discrete graph, it deals whenever variable you're talking about has whole amounts only. So for example, number of pets and students. When you're talking about number of students, number of pets, can you have, for example, a half of a student or 3/4 of a student or 1.5 students? It wouldn't make sense. So you could either have no students, right? 0 students, 1 students, 3, 4, 5. That's what it means to be discrete. And in terms of age and height, think about your age, right? Your age won't skip from like 1 and then instantly go to 2. You have all these, these different ages in between. Like if you're 1 year old, to get to 2-year-old, you have to go into between all those the minutes, the days, the months to go to age 2. So in other words, you could be like 1.5 years old. You could be 1 year old and 7 months, right? So like there's numbers that exist in between 1 and 2 with age, but with respect to number of students, you're not going to have any numbers that exist between 1 and 2, for example, because you won't have, like I said, like 1.5 students. So that's what it means to be discrete when it has to deal with the whole amounts. And continuous means you can have any real number that's going to work, in between. So you can have 1, 1.5, 1.2. All those are appropriate for when we're talking about age because of the fact that we're not going to skip from age 1 instantly into age 2. Right, but with students, you have to skip from 1 student to 2 students. You're not going to have numbers that exist between. So again, this one is going to be discrete when you have to have whole amounts only. And again, this one will be continuous. And let me show you what the graphs will look like. So in this case, let's say one student has 1 pet, 2 students have 3 pets, right? So these are just, some different examples. You can see that we're only going to have different points. And because nothing exists between 1 and 2, you're not going to have any connection between these 2 points. Because if you connect the dots, you're saying that these values exist. But again, since we can't have any values exist here, then there's not going to be any outputs for those numbers. So basically, when you're looking at the graph, you're dealing with a discontinuous graph when you only have dots that are not connected. But then when we're talking about age and height, right? Let's say that you start here, and then at 1, you're at this height, and then, it starts to like slowly increase, and then you have a growth spurt, right? And then it continues on. So basically, right, this is not going to be accurate, but hopefully you get the idea that, let's say this is 1.5 years old, and that was the height at 1.5 years old. At 2 years old, that was the height here, right? You have all these different heights that exist, no matter, at what point you're looking at. But in this case, again, you can't have any numbers in between, which means there's not going to be a point that exists to match up with any of these numbers in between. So there's going to be gaps because of the fact that these only deal with discrete numbers. So basically, in a nutshell, all you have to do is to know if it's discrete is if you look at the graph, you're not going to be connecting the dots. So that's one way to check it if you're looking at it visually. And it's continuous. Notice that the graph continues. So that's where we get that word continuous from.